Hello, my dear warriors. Welcome, Vijay, Anusha, Deva, Vijan, Anish, Madhumita, Epic Queen, Deva, GV, Sampath. Good evening, guys. Yes, the classes have started and the session is live. I hope you guys can see me and hear me loud and clear. Let me know, guys. This is Shreyas here, your captain, your navigator, your master teacher, who has been nurturing kids for a very, very long time, just like you. So many enthusiastic kids, so many motivated kids wanted to get into the top-notch colleges, and I'm very happy and proud to say this again and again that I have been with these kids throughout their journey, helping them build their career, and it makes me very, very happy to see them do really well in life. So today's session is basically the Allied Crash Course 11th standard topic, which is Newton's laws of motion, drawing the free body diagram, talking about the different kinds of forces, also how to write the equations, and then slowly moving ahead towards constrained motion, and then finally ending the class with none other than pseudo force and non-inertial frames. So that's the flow of today's lecture. Make sure you smash the like button and show your immense support as well, and make sure you are subscribed to the channel, because or else you are going to miss out on so many classes, my dear students. And like you can see, I've already put up the schedule on the community post. Many of you have seen that. And guys, you have to be here. You have to be present here in massive numbers. That's the only way I derive motivation. That's the only way I'll feel like doing more for you. You show it. You take one step, I will take 2 steps for you. You take 3 steps, I'll do 6 things for you. Okay, so that's all I am asking from all of you. Sir, our transistor class wasn't done yet. Well, let me tell you guys, if you have not seen it yet, it's here. Okay, just go over here. Okay, do you see this? Where is it? Upcoming upcoming sessions. It should have come. I'm not sure why it's not showing up. It should have shown over here. So basically, let me show you over here in the community I had posted. Okay, so this week, Newton's laws of motion, frames of reference, concepts, theory, etc. Transistors, concepts and problems, that's going to happen tomorrow. Friction theory, concepts, etc. That's on 5th of Jan, and 6th of Jan, that's going to be problem solving of Newton's laws of motion and friction. So that is what it is. I know practicals are going on, so many things are going on, but you have to make up your mind. You cannot ignore the sessions, because once gone is gone. You are not going to get that motivation again to sit and study. Okay, so that's why make sure you attend the classes as and when they are going on. Okay, so let's begin, guys, with the class. It's going to be a 2 hours long class. I think I had mentioned that in the Telegram channel as well. Make sure you join the Telegram channel. The link is there in the description box below. Let's start with the first 3 laws of Newton's laws of motion. See, this chapter mainly deals with identifying the forces, different kinds of forces, in different kinds of system, showing them, solving the equations by drawing something called as a free body diagram, finding acceleration or finding the force or finding the speed by finding the acceleration, things like that. How much is the tension, how much is the spring force, what is the reading, where is it moving, such kind of things. And obviously, you will see many things around you obeying or following Newton's laws. I'm pretty sure you would have heard or even done these kind of experiments where you take a cup, you put a cardboard piece, and you slowly, move the cardboard piece. You will see that as soon as you move that cardboard piece, you will see the thing which is kept on that cardboard will fall down. And you can see just like over here, this tennis balls are kept over that cardboard piece. You move that cardboard piece, you will see it falls down. Why? Because those tennis balls over there had certain mass, they had certain inertia, they wanted to stay there. So the moment you slided the cardboard piece below it, the mass, that balls over there, tried to maintain their position, and they just stayed there because they were not quick enough to move. So that's why they fall down inside the glass. Isn't that true? Hello Asing, hello Tejaswini, hello Roshni, hello Akshaya, welcome Bacha, hello Shafika. All right. So similarly, you would have also heard about things like action and reaction. When you hit somebody, they will also hit you back. So these kind of things are just nothing but good examples of Newton's laws of motion. When you push something, when there is an action, there is a reaction. You do good karma, there is a bad karma. You do bad karma, there is a good karma. Things like that. So that's action, reaction, Newton's laws again. So let's go by one law at a time. Okay. So first law is nothing but, okay. So sorry for asking to talk in English in Hindi language channel. No problem, Unique Boy. This is the English channel out for you. Okay. No problem. Just attend this class for all the students who want to attend NEET classes in English. First law is all about inertia and its tendency to maintain its state. See, every body has a tendency to maintain its state, just like you people. When in the morning, your mom has to wake you up, or the alarm has to ring to make you guys sit up, or let's say you're studying, then you need a friend to call you to play cricket or to play whatever games you want to. So you always need somebody to disturb or unbalance, create some unbalance in your situation. Same way, whenever things are at rest or things are moving, you need to disturb them, meaning you need to apply some kind of an unbalance to disturb them and make them deviate from their path, or to make them accelerate, or to make them decelerate. Other than that, if you don't disturb them, if all the forces cancel each other, then it is said to be a balanced situation. In such a balanced situation, the body keeps on doing whatever it is doing. Imagine a situation where there is smooth surface everywhere. If you push something and leave it, it will keep on moving. There is no friction. There is no resistance. There is nothing to stop it. It will just keep on moving. It will never ever stop. Correct, guys? So Sudarshana, everybody, rotational motion will come whenever it has to. I have given you all the list of important topics. I'll first do important topics, then I'll go to the second important topic. So I'm going to follow high weightage topics first, okay? Right. So here is basically this first law talking about inertia and talking about balanced and unbalanced forces. So what is inertia? Inertia is nothing but your tendency to maintain the motion or basically rest. So everybody tries to have a situation or tries to maintain its state of rest or keep on moving unless it is acted by an unbalanced force. So as long as the forces are balanced, so the meaning of balanced forces means all the forces when added together gives you zero. This force, that force, this force, this force, they cancel out each other. So all the forces cancel out each other. That is set as balanced force. Then what do you see is that the velocity is constant. It maintains its state of motion, or basically it remains zero, or basically it stays at rest. Is this first law clear in your head? Is this first law clear in your head, guys? This Vedantu crash course which I am doing is free of cost on YouTube, bacha, but there is also another crash course which is running, okay? That is paid version. There you get, assignments, you also get your test series, you have doubt solving and other things. Clear-o? Understood-o? Is this formula also clear? Oh, by the way, what is this symbol called, my dear students? What is this symbol referring to? What is this symbol telling you? What is that symbol? Come on, put it up in the chat box. Okay. So Subhash, the link is there in the description box, bacha. Yeah. So what is it? It is called as net, or basically the resultant. All the forces added together. Yes, the symbol is called as sigma, but what does it mean? It means summation or adding, net, resultant. Very nice. Excellent. Awesomeness. The next thing is nothing but the second law, and it talks about what will happen if the net force is not zero. Here force was zero, but what if force is not zero? Then the moment the force is not zero, it will cause acceleration of the object. The moment I say acceleration, it means, what does it mean? There is going to be change in the velocity. Now how can velocity change? By either of the two things. Velocity is a vector, so it has magnitude, it has direction. So velocity can change if the speed changes, that means the speed increases or decreases, or direction changes, that means it turns left or right or up or down. something like that. So the moment the direction changes or the speed changes, velocity changes, it accelerates, and you will see that this can only happen when there is a force. And the better way of writing Newton's second law is that the net force is actually dP by dt. Now you might be wondering, what is this P? This P is nothing but called as the momentum. This is momentum, the effect of mass as well as velocity. If I throw a big rock on you with a large speed, what will happen? It has large momentum. It is going to obviously smash your face. If I take a tiny stone and throw it like this, it has very small momentum. So it's effect of mass and velocity. It's a vector quantity. So what is dP by dt then? What is dP by dt then? The dP by dt is nothing but your rate of change of momentum. That is basically dP by dt. And if you solve it further, you basically get the net force is mass into acceleration. That's a better way of writing Newton's second law, but this is the original form. Net force is the rate of change of momentum. How quickly the momentum changes. If there is no net force, the momentum stays constant. If there is net force, the momentum changes. More force, more fast it will change. Small force, it will change very slowly. Is that clear? Everybody with me? Okay, thank you very much, Jolly Girl. I'm so glad you are watching both the things. I'm pretty sure you are going to get multiple inputs, and that is obviously going to improve your concepts for your betterment itself. Very good, bacha. Make sure you solve all the assignments here as well as there. Great. So what is the third law? Third law is nothing but action, reaction. Reaction, action. So you might be like, what is this? If you do something, there is always some outcome and there is some reaction to it. Like if you study well, you attend all my classes, what is the reaction to that? What is the reaction to that? Obviously, you will get very good marks in your NEET exam. If you don't study, if you don't attend, if you miss the classes, if you watch it after a long time just before the exam, then you will obviously get less marks. So same way, whenever something applies force on something else, that something else also applies force on the first body applying that force. If I apply action, that body applies reaction. These two forces are equal and opposite. That means if I apply 2 Newton this way, that body applies 2 Newton the other way. They are opposite to each other. But the funny part is, what is the funny part? They do not cancel each other. Let me give you an example. Let's say Pandu and Champa are fighting. What is happening? Pandu and Champa are fighting. So this is your Pandu. Okay, and Pandu is pushing Champa or something, pulling Champa, whatever. So they both are fighting or something, they are just playing, whatever. So this is Champa. Can you see that, guys? This is Champa. Now imagine Pandu pushes Champa. Pandu pushes Champa, and Champa, even if she does not want to, will have to push back Pandu. That is unknowing, involuntary. It will happen. That is what third law says. So imagine Pandu applying a force like this on Champa. Let's say it is F. Champa will end up applying a force this way on Pandu. If I call this as the action force, this will be the reaction force. They both are equal, opposite, but like I said, the funny part is they do not cancel. You might be wondering, sir, how is it possible they are not cancelling? Sir, they are equal. No, sir. They are opposite. No, sir. What is the catch, guys? Put it up in the chat box. What is the catch, guys? Like, why aren't they cancelling each other? Because something is happening. Because something is happening. What is that something? Come on, put it up in the chat box, guys. I want to see how many of you can figure that out. And probably I will give you a hint over here. There is F over here. There is F over here. Here, the net force is going to be 0. They basically cancel each other because they are on the same body. Here they are on the same body, that's why they are cancelling. But here they are acting on different bodies. Exactly. Look at this situation. Same body, FF, cancel. F here, F on that. I am getting some force, you are getting some force. We are not the same body. So gone. So they are not going to cancel. Is that clear, everyone? Excellente. Rutushri, very good. Sampath, Vijay, very good. Sumita, very good. Jagan, very good. Agnes, Nandini, excellente, excellente. Very good. So these are the three important laws of Newton. Now, probably we can solve some questions just to warm you up a little bit. Here comes the first question up on your screen. There is a person who is at rest in the middle of a horizontal plane, perfectly smooth ice. So think of a big sheet of ice. This is the big sheet of ice, and imagine a Pandu in between. He's stuck in between over here. Okay, this is Pandu. Okay, so this is a big smooth surface of ice, horizontal. If he has to reach to the shore, this is the shore, right? This is the shore. That means you have to reach the bank, you have to reach the end. How do you make sure this person reaches here? Which law is he going to apply? Anish saying D, GV saying A. Everybody has to participate. Everybody has to stay alive till the end of the session, guys. You have to understand each and every concept. Put in little bit of effort, and even if you lose track somewhere, it's okay. It's okay. Continue the lecture. You can rewind back after the class is over. Okay, don't worry about it. The correct answer to this question, many of you confused between A. Some of you even said C. I can see that. Some of you also said D. The correct answer is third law, guys. So I'll tell you why third law. See what is happening over here. See, here, if Pandu has to reach the shore, he has to do something. What does he have to do exactly? What does he have to do exactly if he has to reach here? Maybe he's carrying a phone, or maybe he's carrying a stone, or maybe he has some small keys or something, or maybe something is there around him. He will just pick it up and throw like this. The moment he throws that object, the moment he throws that object like this, the moment he throws, what will happen? He is applying some force. That means he is applying action. So on him, what will be there, guys? A reaction force will be there. A reaction force will be there, correct? So the law which he is using is action reaction. That means third law. And because of this reaction, he will come over here and reach the shore. So hence, it should be the third law, which is option C. Is that clear, everyone? Sudarshan, now do you know why it is reaction action, which is third law of Newton? If you take something and throw it here, then that body will also apply force on me this way. So if I throw it there, I go this way and I'll end up reaching there. That's Newton's third law, of course. Okay, now let me tell you, it might seem very idealistic, but this is the exact same thing which astronauts do. Have you ever seen some video on National Geographic or Discovery or maybe YouTube or maybe Instagram or somewhere where astronauts walk in space outside the spaceship? They walk in space outside the spaceship. Is there something to hold if they are floating in space? Nicely, if they keep floating in space. Is there something that they can hold? Can they walk on something if they are floating like this? Can they walk on something? No, right? They can't walk. Now, that's why they are tied. They are tied to the spacecraft. There is a small rope. There is a small rope which is tied to the spacecraft. If you have not seen, please watch it. It is very interesting. See, guys, why many people do bad in physics is because you do not have the feel of physics. The moment, if you're not seen something, you cannot understand it. It's very simple. If, imagine you had never seen an elephant. If you have never seen an elephant, how will I describe an elephant? I'll say it has a long trunk. You'll be like, what the hell is trunk? It has teeth outside. It has, big ears. It is very fat. It is very big. It has very fat legs. It has a very tiny tail. Imagine if I ask you to draw such an animal, you will draw something else only. It will look like an alien animal, correct? So that's why if you have not seen something, it's very difficult to visualize. It's very difficult to get a feel of it. So that's why please watch certain videos. Please watch or understand it through examples, maybe through newspapers, maybe through magazines, maybe through pictures, maybe through videos. Then you will get, oh, this is how it works. So coming back to that example, these astronauts are tied using a small rope because they can't hold on to anything. It's gravity-free space. By chance the rope gets cut, what will happen? By chance the rope gets cut, what will happen? They'll just drift away, right? They can't just do this. They can't just do this. Gone. They're lost. They're gone. They just keep floating, gone. Zoop. So what they have is a small stone, basically a small brick kind of thing. In case they drift apart, they take it and they throw it on the other side. So then they get a reaction force and slowly start moving towards the spacecraft. They use Newton's third law. Okay? So that's what it is. Moving on to the next question. Which of the following has maximum inertia? Atom, molecule, 1 rupee coin or cricket ball? Everybody has to give this, guys. I'm waiting for all your answers in the chats. Quickly. Atom, very, very small. Molecule, little bigger mass. 1 rupee coin, slightly more mass, more inertia. Cricket ball, oh my god, it has a lot of inertia. It's heavy. Have you held it any time? Yes, it is option D. Very good, Sampath, Jivi, Deva, Tirshika. Very good, Sumita. Very good, Jaya. Very good, Madhumita. Very good, Agnes, Adi, Priya. Very good, Tarika. Very good, Vicky. Very good, Niranjan. Excellent, Eliba. Very good, Navya. Very good, cute videos. Very good, everyone. So that's the correct answer. Moving on to the next one. If the force on an object is doubled, so there is an object, you double the force. And the mass, you make it half. Reduce the mass. What will be the ratio of the acceleration? Don't make stupid mistakes or else you will get the wrong answer. Okay, just use, I think F is equal to ma, that should give you the answer. We all know, since F is equal to mass into acceleration, I can say F1 by F2 is equal to m1 by m2 into a1 by a2. You can see the force is doubled. That means the new force is 2 times the old force. So this is 1:2. Everybody, if this was old force, the new force is 2F. Okay, mass wise, the mass is made half. So if the old mass was m, the new mass is m by 2. And this is nothing but a1 by a2. FF cancels. So 1 by 2. 2 goes on the top and again comes below. Okay, if you don't get it, no issues. I'll just write it step by step. 1 by 2. This will become 2 by 1 into a1 by a2. So therefore bring this 2 below. So 1 by 2 into 1 by 2 is a1 by a2. So a1 by a2 is 1 by 4. 1:4 is the answer. Where is it? No, it is C option, guys. C option. Lot of you wrote D. Made a silly mistake there. Somebody has, in fact, a lot of people have made the silly mistake. So you're going to get a negative mark over there. So that's how you're going to lose marks in the exam. That's how you have to avoid it. That's why you are attending my classes here, so that you know what mistakes have to be rectified. If you don't know what is wrong, then you will definitely get less marks in the exam, right? So be very careful with the ratio wale problems, because often people make a mistake, they invert it or do something wrong while calculations. So that's a simple problem on ratio proportions. Now let's talk about different kinds of forces. Which all kind of forces have you heard? Or wherever you are sitting, can you think of the different forces acting around you? What are the different forces acting around you? Wherever you are. Maybe you are in a car and watching my video, or you are in the house, or maybe you are sitting on the back bench of a classroom and watching my lecture, whatever. So guys, what kind of forces are there around you? So Sumita saying frictional force is there. Others, what kind of forces are there around you? Yes, somebody is saying gravitational force is there around us. There could be also, what else? Okay, no, conservative, non-conservative, that's a different category. I'm talking about types of forces. Frictional force, spring force, okay, Agnes sitting on a spring maybe. Centripetal force, okay, it's not even a force. Centripetal is a name given to force. So guys, centripetal force is not a force, please understand that. Normal force, yes. Gravity, yes. Okay. And what about air friction? Yes, very good. What about contact force? And what about tension? Electrostatic force, very nice. So some people have tension. That I don't know what kind of tension. Is it the tension of NEET examination, or are you hanging somewhere? That's why you have tension. Okay, electromagnetic. So these are the different kinds of forces. We will start by the simplest of the forces, because we are going to study few of them. In 12th standard topics, you will see the other forces like electric, magnetic and nuclear forces as well. Impulse is not a force, bacha. Viscous force, very good. You will study about it in the chapter of fluid mechanics. Very good. Radiation force is again not a kind of a force. you will see it is more like a contact kind of a force and all that. Anyways, we'll talk about all of that. Some of these forces in 12th standard, some of these forces are in 11th standard. The first one that we are going to talk about is nothing but weight, or basically gravitational force. Now, what is the meaning of gravitational force? Observe this carefully. Let's say this is our earth. Okay, you take anything on the earth, maybe something like this. This is a ball, this is an object, whatever. That object will always experience the gravitational pull towards the center of the planet. That gravitational pull is only called as the weight of the object. So the weight of the object, which has a symbol of W, is the gravitational pull by that particular planet, and that is given by mass of that object into acceleration due to gravity. What is the value of acceleration due to gravity? It is 10 meters per second square usually. Otherwise, you will take it as 9.8, okay, depending on what is given in the problem. So weight is nothing but mass into acceleration due to gravity. As simple as that. This weight is a vector quantity. Please understand that. It is a vector quantity. Number two, it always acts towards the center of that planet, or you can just say downwards, vertically down. That's very, very important. Just to give you an example, let's say Pandu has a mass of 60 kg. Quickly tell me in the chat box, what is the weight of Pandu? Pandu has a mass of 60 kilograms. What is the weight of Pandu? Come on, my warriors. Come on. Absolutely tension of NEET, sir. Okay. So what is the weight of Pandu? It will be 60 into G, right? Which is 60 into 10, right? Which is nothing but 600 newtons. Everyone, very good. This is newtons. What is Newton? Newton is the unit of force. 1 Newton is 1 kg accelerated with 1 meters per second square. That's the weight of Pandu. So you might be like, sir, when I ask my friends, then they do not give the answer in Newton. What is this exactly problem? So understand, when usually you talk to your friends or your relatives, when you ask somebody's weight, what they mean in English is mass. But in physics, weight means weight. It means force. It is in Newton. Now next time your relative asks you, what is your weight? Then don't say, my weight is 450 Newton. Your relative will be, what? 450 Newton, what is this? Then you just like, calm down. 450 Newton is just 45 kg. Then you're like, oh, okay, is it? Okay, fine, great. So, people generally when they talk in English, they usually mean weight means mass. So don't get scared by that. Oh, by the way, there is also one more unit of force or weight, and that is kgf, not that movie that you have seen. So 60 G weight or 600 Newton weight is nothing but 60 kg force, kgf. Basically 1 kg force is 10 Newton. So 60 kgf is 600 Newton. Is that clear? KGF, how many of you have seen KGF, guys? If you have seen KGF 1 and 2, write both. KGF 1, 2. If you have seen only KGF 1, write KGF 1. How many of you have seen KGF 2 only? I'm pretty sure none of you would have seen just KGF 2. You should have seen KGF 1 then. That's the direction of the dipole moment. Anish, we are not discussing dipole moment. Let's not, deviate from the topic there. Yes, both. Very good. Very good. KGF 1 and 2. Jigan saying nothing. How many of you have seen all my previous lectures? How many of you have seen all my previous lectures? Now comes the real colors. Both. Now have you seen all the lectures? Okay, then it is good. If you have seen all my lectures and then you have seen KGF 1 and 2, then it is okay. If you have just seen KGF 1 and 2 and not all my lectures, then bad, guys. Okay, very good. Thank you. Okay, so that was weight, for all of you. Okay, I have one more question. Like, imagine these couples these days, you know, they promise, I will bring the moon for you, I will take you on stars, I will take care of you so well, you will feel like you are flying on the moon and God knows what. Okay? So imagine Pandu promises Champa. What does Pandu promise Champa? Listen, I'm going to take you to the moon. And he keeps up to his promise and he takes Champa to moon. The moment Champa and Pandu go to moon, what happens is Pandu's mass will change or weight will change. Answer in the chat box. Pandu's mass will change or weight will change. Answer in the chat box. Mass or weight? Will Pandu still be 600 newtons? Or will his mass be still 60 kgs? Yes, the weight will change. Why? Because g will change. Because on moon, acceleration due to gravity is not 10, it is less than 10. It is 1/6 of that. So Pandu's weight will reduce. But Pandu's mass, that will not change. So mass is the amount of matter, whereas weight is the force. And that force can change from place to place or depending on the situation. Very good. Awesomeness, guys. Next important thing is contact force. What is it? Contact force. Let me write it down. Contact force. Now this contact force obviously will come into play when two objects are in contact. They are touching each other. Example, this is one body which is touching another body. This is another body. This is basically contact, or basically they are touching each other. So moment two things touch each other, there are two lines you should immediately think of. One line is basically if you draw a common tangent. When you have two surfaces touching, if you draw a tangent which is common to both of them, that is called as the common, what? Tangent. If you draw a perpendicular at that location where they are touching, that is basically called as the common what? Because it is perpendicular, right? So it is called as common normal. Everybody clear till this point? Common tangent, which is parallel to the surfaces. Perpendicular one is common normal. When these two surfaces touch, there is something called as the contact force. And that contact force might act at any angle. So this is C, which is nothing but your contact force. That is C. Okay, very crucial. This C can be split into two new forces. This C can be split into two new forces. Hello Subha, hello Nidalanes. And one of those forces here, which is parallel or basically along the common tangent, is called as friction. And that force which is perpendicular or along the common normal, that is basically just called as normal. So the contact force is a vector sum of normal force and the frictional force. This is called as normal force. This is called as the frictional force. You might have heard friction. There is a lot of friction when you rub two surfaces or a surface is trying to move. The force which prevents the motion is called friction. Normal acts perpendicular. Normal means only perpendicular. Is that clear now? So a lot of people did not know that contact force is actually made of normal and friction. People always think contact is different, friction is different, normal is different, but little do they know the components of components of contact is normal and friction. Very, very crucial thing. Let's see if you guys can figure this bit out. If I ask you what is just the magnitude of contact force in terms of N and F, what are you going to write? Come on, my dear students. If I just ask you the magnitude of C, I'll just give you a hint. Take this normal and shift it over here. I think you can see a beautiful right angle triangle. Take this normal and shift it over here. You can see this right angle triangle where contact is the hypotenuse. This is base, this is height. Use Pythagoras theorem. Contact force square is this square plus this square. So that's it. No, it is not n square plus f square is root. Correct. So it is root of n square plus f square using Pythagoras theorem, of course. Excellent, guys. Wow, you guys are brilliant. Yes. Aishwarya, Tattva and NCERT is more than enough. Sari Sivagami, right now my class timings will be either at 9 o'clock or 7 o'clock or 5 o'clock. Tuesdays, Thursdays, generally 9 o'clock. Generally other days 7 o'clock or 5 o'clock. The reason why I don't have consistent timings is because I am there on other channels also. So managing all the channels, managing all the slots, adjusting with all the teachers takes a lot of effort, guys. I mean, it's not possible only. It's not about effort also. If it took some effort, I would have done it, but it's not possible only. Because every teacher is interlocked. So that's why I update the schedule. I started it from this week by putting it in the community post. Okay, great. So I'll post it on the community, and also I'll try to post it on the Telegram channel. Okay, moving on ahead to the next one. So normal force like this one. Look at this book kept on the table, normal force. This toy, it's making contact, there is normal force. This beautiful cat sleeping over here, normal force will act on the cat. So normal force is there everywhere. If there was no contact, there will be no normal. Friction, look at this dude pulling this box, or this person pushing this sofa. Every time you try to push or pull something, you will see it slides, it rubs, and there is friction, which is basically there parallel to the surface. You will see friction is there parallel to the surface, right? There is a separate lecture which I am going to dedicate for friction. So we are not going to spend time on friction in this basically in this particular lecture. Okay, let's go to tension force. Everybody with me on this? Sudarshan, I cannot take sessions in the morning, bacha, because I am involved in other departmental activities. Like you all know, I am leading the physics department over here. So all my admin work or operational work and scheduling and so many other things happens in the morning. So that's the reason why I generally do not take classes in the morning. Okay, great. Now what is this tension? Tension can happen in strings, ropes, or slender objects like the one over here. This is my microphone wire. I don't know whether you can see it. It's very tiny over here. So this is a wire. If I just leave it like this, if I just leave it to hang like this, it does not have any tension. The moment I pull it, if you have some rope around you, okay, if you have some string lying around, just pull it. You will feel the tension. If you pull it hard, you will see the tension increases. You can really feel the tension. You just do this, you just do this, you will feel the tension, correct? I don't want to pull it hard enough or else my microphone wire will break. But anyways, you get the idea. So that is basically the tension force. It acts in strings, etc. Tension, if it is 0, the string is said to be slack. Slack meaning no tension. It's no longer tight or taut. Okay. So I'll just put it up here. If tension is 0, that implies the string has become slack. If tension is not 0, that means the string is basically tight, or just simply put taut. You will hear this word very, very often. You can see this crane pulling this car, or cranes have so many strings, or elevator, lift has so many strings. There is a lot of tension in the strings. If you hang a mass, obviously that also has a lot of tension in it. If you add more mass, there is a pulling force which is created that creates more tension. The tension is because of the intermolecular forces. When you apply some weight, the string tries to stretch. These molecules try to go away from each other. There is these molecular forces which try to bring these molecules back. So that is manifested as tension. Just to give you certain examples where you can calculate tension, look at this. There is this wall, there is this rope over here, and what I do is I apply a force from this side. I apply force from this side. And I ask you, is there tension in the string? You'll be like, yeah, there is a rope, I'm pulling it. Obviously the string has become taut, I can feel it, I can just sense it. Yes, there is tension. Now if I ask you how much tension is there, I'm just going to break that rope into few pieces. Not actually, only in my mind, only in the diagram, only on paper, that's it. So one piece is over here, the other piece over here. This is just a mental picture, nothing else, guys. So what you will see, if I show the forces, there is a force F from here. This piece stays as it is, so there must be something to counter it. That force to balance it is tension, because it is acting between these two places. Here also there will be tension. You can see, if this I call it as the action force, then this will become the reaction force. If this applies force on this guy this way, this applies force on this guy this way, action, reaction. And because on this piece, there is a tension force this way, the reaction or basically a balancing force will be from here. So that will be the force by the wall, okay, on that rope. Everybody clear? Excellent, understood? No, there is tension, Priya. A lot of people think there is no tension. There is tension. You can think, you take a rope attached to the wall and pull it. You will feel that rope is under tension. Just visualize this. Correct? And the value of the tension in this case will be equal to F. What if I change the situation a little bit further? What if I hang something through that rope? Okay, let's say a mass, maybe like this, mass over here. Now, if you just consider, okay, maybe that mass which is, okay, just hanging separately with that rope. Okay, so this is that mass, this is a part of that rope, this is the remaining part of the rope. So the forces acting will be something like this. On this mass, the weight of that mass will act like this downwards. Because I've taken a small part of the rope, you can think of as if there is tension acting this way. The reaction of this will act this way. Correct, guys? Everybody with me? I've just taken a small part of the rope just to make you visualize how the tension pulls up the block upwards like this. The weight is acting downwards. So both these forces, because the object is at rest, that's why they should cancel out each other. So tension should be equal to mg. Why? Because the tension is just holding up the weight. And this tension will be balanced by the force on the roof, or by the roof, sorry. The force by the roof on the string. Everybody understanding this? Clear how to calculate tension? Whenever you have to find tension, cut the string, not actually, in your mind, on the paper, and show the forces for individual bodies, either this or that. Immediately you can find the value of tension force. Also remember, the direction of tension depends on which part of the string you are referring to. Like over here, at this point, if I ask you where is the tension, it can be either up or it can be down. If you take the up part, it is down. If you take the down part, it is up. Over here, if you take this part, it is left. If you take this part, it is towards the right. So the direction of tension always depends on which part of the body you are talking about. Also keep in mind, tension can always pull, tension can never push. That means if I have a rope, then this is possible. So tension over here is basically pulling that rope. But this one, look at this, this way, this is not possible. This is not possible. How can you take a rope and push it from both sides? It will just bend down. It's just going to become slack, right? The rope will just become slack. So this is not possible. Okay, all these are important pointers regarding tension. I'm discussing each and every force with you in detail, guys, because I want to understand all these concepts. In the problems, I don't want you to get stuck. That's all. Next force is the spring force. Yes, tension is always away from the body. Very good, Priya. Very good conclusion. Now, spring. Have you ever seen a spring in your life? Because see, if you have not seen now, it becomes difficult to visualize. If you have not held a spring, again, you will not get the feel of it. If you're not, I'll tell you best simple way. You take a pen. You have these ballpoint pens where you just press the pen and the nib comes out. Have you heard this sound? Yeah, there is a spring inside. Now, I don't want to remove this pen's mechanism. There is a spring inside. This pen was gifted by one of my students. It's a Parker pen. I just keep all the gifts which my students are given everywhere around over here. Anyways, so this is again having a spring inside. You might have seen it in suspensions of cars or bikes as well, right? Cars and bikes as well, right? Have you seen that? Very good, guys. Keep it up. So all those are good examples of springs. Springs are flexible bodies. There is a coil in it. It will have certain thickness. It could be made of different materials. It is difficult to extend or compress a spring. Very difficult to extend or compress the spring. And you will see, the more you extend, the harder it becomes. The more you compress, the harder it is to compress it further. So this force which is required to extend or compress a spring is a variable force, and it completely depends on how much is the extension or how much is the compression. Correct? And this force can be easily written down like this. Observe now. Imagine I have a spring which is right now not experiencing any force. It is basically in its natural form. There is no force acting on it. Now what I do, I basically either extend it or compress it like this. So you can see this is basically the extension X, or maybe I just happen to compress it. You can see this is the compression X. So this is your extension or basically the compression. Okay. In either of the case, you will have to apply some force on the spring. On the spring, you will have to apply some force. Let's say on the spring you applied a force of F. Because you have to pull it, you have to apply the force. If you have to push it, you have to compress it, you have to apply the force in this particular direction. Everybody gets this. So this is the force which is going to be applied on the spring to compress it. Cool. If on the spring, while extending it, the force is this way. Imagine I'm pulling the spring, I'm applying the force this way. On my hand, which direction will the force be applied? On the hand, which direction will the force be applied? Come on, quickly put it up in the chat box. Quickly put it up in the chat box. If I pull the spring this way, on the spring the force is towards the right side. So on me, exactly opposite, Newton's third law, that side, correct? Very good. So on the object pulling it, this is basically that object pulling or pushing the spring, the force will be exactly opposite. Now this force is basically found out to be proportional to the extension or the compression, and the magnitude of this force is given by just k times of x, Now this k is just nothing but called as the spring constant, unit of which is in newtons per meter. You can see why. This is Newton, bring meters down, Newton per meter is the unit of spring constant. It tells you how hard it is to pull the spring per unit meter. If it has higher newtons per meter, it's very difficult to pull. You have to pull by applying larger newtons per meter. If it is a soft spring, it will have lower newtons per meter as the spring constant. Now, a lot of you might have seen negative sign. Don't get scared by it. If I take this force or this force, that decides the sign. Observe why. When I take the force on the spring, this force is in the direction of the spring's pull. This force is in the direction of the spring's push. So F and X are parallel to each other. So no minus sign. But force on the object, pulling it or pushing it, you will see F is opposite to X. Here, if you draw that object which is trying to push it, the force which the object applies is this way. So on the object, it will be this way, right? So don't you see it is opposite? So this F will be then equal to minus kx. So that's why I say do not remember the sign. Just remember one thing, and that is that the force magnitude wise is just k times of x. This is the thing which you're going to remember. Because whether to put minus or plus, it's a crazy thing to do. Whether to put that minus or plus, that's a crazy thing, right? Chiru, watch my strategy session which I have put up on this channel few days back. If you watch it, everything will be clear. Which books, how to study, etc., etc. So whenever you show spring force, just show kx. Do not put minus kx. Is that understood why you are not going to put minus kx? Because depends. What does that F mean? And in many books, they write spring force is restoring, it pulls it back, so it's opposite to the extension or compression, hence that minus sign is there. Array, but which force are you talking about? Are you talking about the force on the spring or on the object? If you are talking on the spring, it should be plus kx. If you are talking on the object, they are opposite. It should be minus kx. So better na, remove that headache. Magnitude is kx. Plus minus, forget it. Just show the direction. It is this way or that way. Makes sense, right? Makes sense, right? Correct? Pakka? You're not going to say, sir, I have been walking 5 kilometers, minus 5 kilometers towards the south. Array, what is this? I have been walking minus 5 kilometers towards the south. Just tell, no, I have been walking 5 kilometers north. Just tell, I have been walking 5 kilometers north. It's the same thing. Don't say, sir, I have been moving minus 20 kilometers per hour in the east direction. Just say you've been moving 20 kilometers per hour in the west direction. Why put that minus sign? Doesn't make sense. Okay, great. Now comes the next part, and that is something which everybody is waiting for as well. What is it? FBD, force body diagram or free body diagram. What is it? Simply put, showing the forces acting on a body. Now you'll be like, such a simple thing. Why do waste so much time? Let's solve some problems. Yeah, we're going to solve problems, but you need to know what is FBD, what are the things you should be aware of, what are the things you should not show, and what are the things you should show, and what can you get using a FBD. Now, whenever you have a FBD, force body diagram, you show the forces, their magnitudes with the proper direction arrow marks, if you know them, obviously, in that particular diagram, and you show these forces acting on the body. And when you show these forces acting on the body, okay, just hold on. How does it look like? Let me just take a simple example. Okay, just imagine there is a rope. This is Champa. She's hanging on that rope like this. Who is this? Champa. Everybody can see, right? Beautiful hair. Okay, this is Champa. Now Champa will be rescued by whom? Who will be rescuing Champa? Pandu, right? Obviously, Pandu will rescue. How Pandu will rescue? Imagine there is a truck over here. And on the truck, Pandu is standing. He is hero of this movie. And Pandu is going to hold Champa and pull her back, and he is going to put her safely on the truck. That is the movie scene. That is the movie scene. Okay? Everybody understood what is the movie scene? Pandu is going on the truck, Champa is hanging, Pandu picks up Champa and puts her on the truck. That is the movie scene, guys. Let's understand how will the free body diagram look like. Okay. Example, let's draw Champa's free body diagram. Everybody ready to draw Champa? Everybody is excited, I'm pretty sure, the moment you have to draw Champa. I'm pretty sure many of you have already drawn Champa now. So this is Champa. This is Champa. Think, what are the forces acting on Champa? Think logically. Champa is hanging. Just think about Champa, guys. Think about Champa. One force is tension, right? One force is tension, right? So Champa is experiencing tension from the string. Everybody agrees? Very good. No, there is no normal as such, but yes, there is, because of Pandu's hands. Pandu's hands are pulling her. So Pandu is pulling her like this. So shouldn't there be some kind of a normal force like this? Oh, there is one more thing which you might have forgotten, and that is basically the weight of Champa. Weight of Champa, tension and normal. Isn't that? Yes, very good. Weight, which is going to be m into g. Perfect. Now if I ask you, let us draw the forces acting maybe on Pandu. If I ask you, let's draw the forces acting on Pandu. This is Pandu's hands. Okay. What are the different forces? Again, think about it, guys. One will be obviously Pandu's own weight. Pandu's own weight. Pandu is standing on the truck, so the truck will exert some kind of normal. Correct? And because Pandu is pulling Champa like this, Champa will pull Pandu like this. Action, reaction. Very good. So there will be a reaction normal. There will be a reaction normal. Just let me put it over here. This normal and this normal are basically action reaction pair. Action reaction pair. Everybody agrees? If Pandu pulls Champa, Champa also indirectly pulls Pandu. Exactly. So these are the forces. Maybe he's standing on the truck surface, maybe the surface is rough, so there could be even friction over here. There could be even friction over here, like this, always parallel to the surface. So these are the typical forces which can come. I've just shown you some example. So whenever you show FBD, forces acting on the body, right? You just take a body, either Pandu, Champa, truck, pulley, mass, blocks, wedge, anything, and then isolate it and show only the forces acting on the system properly. That's all. That is what a FBD is. Great. So key important words: forces acting on the system. That's very important. Never ever show forces by the system. Look over here. Normal acting on Champa, tension acting on Champa, weight acting on Champa. On this Pandu, force acting normal on Pandu, force of normal acting on Pandu, friction acting on Pandu, weight acting on Pandu. You never show forces by the body. Okay. Next important step while solving problems is that you will split the forces if needed. You will generally see the forces will be perpendicular to each other. In X, in Y, in Z, it's good. If it is at an angle, have you learned the concept of resolution, vector resolution? You split the vectors, Fx, Fy, Fy, Fz, Fx, Fy, Fz. You split the forces into 3 or 2 components. So you split it to make it easy, because it is easy to solve problems where everything is in X or everything is in Y or everything is in Z. So that's what you do to solve the problems when the forces are at an angle. And then finally you write the equations. What are the equations that you are going to write? F is equal to ma. Now this might seem more of a theory. You'll be like, sir, let's solve problems. Then probably we'll get some idea. That's right. We're going to solve problems to see how exactly you come to the equation part just from the free body diagram. Okay. So let's start with it. Everybody with me? Okay. Here is the first simple problem. Read the question, everybody with me. A force is applied on a book, or basically on a block, in order to move it on a desk, and it is given rightward acceleration. Consider frictional forces. It is accelerating. Question is, draw the diagram of the forces on the book. So there is this rough surface over here. There is this rough surface over here. There is a force acting on it. Let's say I call it as F. This force is basically F. Think quickly and tell me in the chat box, which are the other forces acting on this book? Come on, put it up in the chat box. Waiting for your answers. Everybody. What are the other forces? Look at the book. Think. It's moving towards the right side. What are the other forces? Okay, Jigan says normal. Tarika says normal. Very good. So let me put normal. Very nice. Normal will always act perpendicular to the surface. Somebody also said friction. I can see that. Where will friction act? If it's going that way, friction will always oppose the motion. So I will show friction this way. Okay. Anything else? Somebody also said weight. Very good, cute videos. Very good. Everyone saying weight. So there will be weight also, and that will be nothing but M into G. These are the forces. Now, whenever you show FBD, there is one more thing you need to show apart from the forces. Everything is done, but there is one more thing. What is that one more thing? That is acceleration. And it is going to accelerate towards this side. Now, whenever you show acceleration, never show it acting on the body. Is acceleration a force or it's the effect of force? Put it up in the chat box. Very good, Roshni. Excellent. So is acceleration a force or the effect of the forces? Acceleration is not a force. It is the effect of forces. Because there is force, that is why it accelerates. If there was no force, it will not accelerate. Correct. So it is the effect. So never show it acting on the body. Now you can see all the forces are in Y or in X direction. So you don't have to break your head or split any of the forces. So I will say in the X direction. In the X direction, which force is in the direction of acceleration? Capital F. This small f is opposite to the acceleration. So can I just say plus F minus F, external force, frictional force, is mass into acceleration? Everybody follows this. This is nothing but Newton's law. Net force is mass into acceleration. Just think about this. Net force is mass into acceleration. This was the law that I have used. In the y direction, what is it that you can say? Oh, normal is up. Perfect. mg is down. Okay, fair enough. Is equal to mass. Oh, but there is no acceleration in the y. Why did I put 0? Because in the y-axis, there is nothing going up or coming down. So there is nothing in the y direction. So 0. From this, I get normal force is equal to mg, and acceleration from here is F minus F divided by m. Is that clear? This is how you bring in equations from a simple free body diagram. Very nice. Excellent, guys. Let's do some more questions. Are you getting some confidence? Okay, let's go ahead, and I hope you have smashed the like button. In case you haven't, please do that right now. Oh my god, this is really a crazy situation. Some guy is just hanging, doing some gymnastics, hanging from 2 ropes. I'm pretty sure you would have also done that. Maybe you even had a competition in school who can hang, like this for a long amount of time. Crazy, your hands will start paining. So this guy is clearly under a lot of tension. In fact, we have to find, show the forces and find all the things relevant to this system. Let's do this. Let's draw the free body diagram of Pandu. Let's draw the free body diagram of this particular Pandu. This is our Pandu. His hands are being pulled like this. Quickly name the forces in the chat box. Yes, GV saying tension and mg. Very good. So many of you already know what question I'm going to ask you. Very good. So there is going to be, keep chatting guys, keep posting. That will obviously activate your brain. If you just watch it like this, like a movie, then it's of no use. Okay. So guys, there is going to be weight, tension. How many tensions should I show? 1 or 2? 1 or 2? mg, 2 tensions. Very good, Priya. Excellent. Okay. Will the 2 tensions be equal? Assuming that he is hanging equally, symmetrically. His head, everything, torso, everything is in between. So it will be equal, right? So there is no extra weight on one side. So equal. So I think I'm just going to put tension over here. And I'm also going to put tension over here. This is also T. This is also T. Perfect. And is he in equilibrium? Is he accelerating? Is he going down or going up? No, right? So his acceleration, the effect is 0. Such a situation is said to be equilibrium. Equilibrium. Very, very crucial. Equilibrium, you will see acceleration is 0. And in such cases, all the forces are balanced. So basically you will have balanced forces. When I say balanced forces, what do I mean? Whatever forces act up will equally be compensated by forces acting down. So what are the forces acting up? T and T. What is the forces acting down? That is mg. So T plus T minus mg will be 0. Or 2T is equal to mg, or T is equal to mg by 2. Half the weight is on one hand, other half is on the other hand. If it was an octopus, how many legs will it have? 8 legs. So one leg attached here, one leg attached here, one leg attached here, one leg attached here, 8 legs, 8 tensions. So 8T will be mg. Tension on each leg will be mg by 8. So each leg will just have to bear 1/8 of the weight. So because we are humans, we just have 2 legs. So fine, it's mg by 2. Crazy. Very nice, Deva Madhumita. Very good, Priya. Very good, Agnes. Very good, Jigan. Excellente, excellente. You guys are thinking and actually imagining an octopus there. Very good. That's what you have to do. That's what I want you to do. When you learn from me, by the time you pass out, you'll be like, sir, because I studied from you, my visualization has improved. I'm able to think craziest of the things. I used to always think, why to think like this? Why to think like that? Oh, this cannot happen. You have to think crazy, guys. You have to think of octopus hanging from the roof. If you can't think of an octopus hanging from the roof, you are not having those visualization skills. You have to build it slowly. That is what is needed to learn physics. All right, moving on to the next one. Perfecto. Very good, Niranjan. Imagine something gets stuck, like you are playing cricket or maybe football, and maybe behind the couch or sofa or between the bed, something just gets stuck, like this ball. What are the different forces that you are going to show? Quickly show the forces acting on the system, guys. Let's have a look. One will be obviously its weight. So I'm just going to show mg over here. What else? I'm also going to show normal over here. I'm also going to show another normal over here. If these angles are not equal, n1 and n2 will be different. N1 and n2 will be different, correct? Normal, two normals and one weight. Very good. If you look at it as a point, right, then you will see there is one mg over here, there is a normal n1 over here, and there is normal n2 over here. That's a simpler version of this diagram. This n1 is from this side, n2 is from this side. I'm showing it like a dot. If you want to solve it further, you can split n1 and n2 into two components. n2 into two components, n1 into x and y components. Do you understand what I have done over here? There are two components of n1 and n2. This is like your n2 x, this is your n2 y, this is your n1 y, this is your n1 x. Why did I do this? Why did I do this? Because the forces are at an angle. So whenever it is at an angle, you split it. Angle, you split it. Now can you tell me, if I write an equation in x, which two forces will cancel each other? If you write an equation in x, which two forces will cancel each other? Can you see that? Yep. n2x minus n1x is equal to 0. So therefore n2x is equal to n1x, guys. That's one equation in x direction. If you look at the equations in y direction, what will you say? This and this upwards, n1y and n2y upwards, balanced by mg, correct? Balanced by mg. So n1y plus n2y is equal to mg. That's about it. Great, great, great. So this is plus over here, not equal to. Be little bit careful. Yes, there is a plus over there. So these two forces balance this. This balances this. That's how simple these questions are. These kind of questions are very important for you to get a good grip on Newton's laws of motion. Now, this looks like a simple problem, but many people make many mistakes in this problem also. Still, we are going to do it. One mass is kept over another mass, and the question is draw their free body diagrams, find n1 and n2. n1 is acting in between them, n2 is acting between the block and the ground surface. So let's start with m1, guys. Okay, so this is your m1 block, this is your m1 block, and this one over here is the lower block, which is kept on the ground surface. On m1, what are the forces? Obviously its own weight, so m1g. Is that all? m1 is kept on m2, right? Because the weight is acting and pulling it down, it will be pushed up by m2 from here. It will be supported. So from below, it is obviously supported like this. So I'm going to call n1. Is it moving up or down? Neither. So acceleration is 0. So n1, so therefore n1 minus m1g is 0. So therefore n1 is equal to m1g. Everybody with me? So this is one of the forces. This is one of the forces. Everybody with me? Very good. What about m2, guys? Think about the forces acting on m2. On m2, obviously it will be pulled by the earth. So do not forget its own weight. The earth below is supporting that block and the upper block together. So it is going to apply a force like this, which is n2, which I am calling it as n2. I think there is one more thing missing. Good evening, Santhamis. Wow, what a name. There is one more thing. Agnes has already put up the answer. Okay, let's see if you guys are correct or wrong. From the top, there will be a force. You know why? If m2 applies n1, then m1 also applies n1 on it. Action, reaction, believe me. So if this is called action, then this will be the reaction using Newton's third law. Now, again use net force is 0 because it is no longer accelerating. So upward force is n2 is balanced by downward forces. So sorry, m2g is equal to 0. So therefore n2 is equal to n1 plus m2g. But wait a minute, n1 is m1g, so this will be m1g plus m2g. So I can just take g common outside, so it will be m1 plus m2 into g. That's the value of your n2. Is that right? Great. Okay, excelente. Santhamil. Okay, Santhamil. Nice to see you. Your pronunciation is probably different than your way it is spelled maybe. Okay, so this is how you show the FBD. The common mistake is this one. Many people forget N1. Many people forget that this reaction will also be there. And many people make mistakes with the signs over here also, even after getting this. Okay, so that was your block on block systems. Next, block with block but sideways. All kinds of questions I am going to do. Rohit, this is for NEET 2024 only. Yeah, 11th standard topic, no? NEET 2024 and 2023. Both. Even droppers. All of you should be assembled over here. Okay? Hello Dharni, hello Milai. Welcome Bachalo. Draw the free body diagram and write the equations. Block after block. First thing, what should click in your mind? Show this guy separate, show that guy separate. Okay, let's do that. M1, let's show it separate. M1, let's show it separate. Okay, and M2, let us show it over here. This is your M2. Do you think when you push them, both of them will move together, na? Both of them will move together, correct? Okay. So they will have some acceleration. So how about showing that acceleration over here? Same acceleration, do you guys agree? Same acceleration, if this goes x, that also goes x. If this goes with 5 meters per second square, that also goes with 5 meters per second square. Now let's show the forces. Obviously this force is acting on M1, show F. There will be a normal and weight. But I don't think I'm so much interested in normal and weight. Why do you think I'm not so much interested in normal and the weight? Because this is not going to give me anything useful. I just know, okay, normal will be balancing the weight, N1 will be M1G. What will I get from that, right? So no point spending a lot of or wasting a lot of time over there. Here also normal will be balanced by weight. I'm just keeping it just for our knowledge. I know something is there, but not of much use. Now I feel if there is friction, I should also show friction over here. If there is friction, I should show F1 and I should show F2. Why am I showing this way? Because obviously if it goes right side, friction will pull it back. Opposing. Friction always opposes. I think still there is something missing over here. Sir, N2 plus M2G is equal to N1 in the previous question. Vidyasri? No, bacha. N2 plus M2G? No. See, N2 is acting up. M2G is acting down. N1 is acting down. So if N2 is positive, M2G and N1 both will be negative. So N2 balances N1 and M2G. Don't see where it is acting, see how it is acting. Okay, that's the mistake you are taking. Sorry. Oh yes, very good Priya and very good GV. Excelente. The contact force, very good Roshni. Yes, the contact force. M1 will apply some kind of normal this way, contact, or some kind of normal this way. Will these two be equal? Yes, they will be. Why? Because they are, again, if this is action, believe me, this is reaction force. M1 applies M2, M2 applies M1. That's it. Now the FBD is complete. Now write the equations for M1 and then for M2. How will the equations look like? Come on, let's start with M1. For M1, what will happen? Okay, this force is in the direction of acceleration. F1 is opposite to acceleration. Normal is also opposite to acceleration. So I'll take this as positive. So plus F. F1 is opposite. So minus F1. This normal opposite. So minus normal. That's it. Nothing else is there. Is mass into acceleration. Is M1 into A. Correct? Similarly, over here, what will be the equation? There is one force in the direction of acceleration, that's plus N. So plus N, that's it. Here if you see force 2 is opposite to acceleration. So minus friction 2 is mass into acceleration. That's all the equation will be. N minus F2 is mass into acceleration. Are you getting a hang of how to write the free body diagram, draw the free body diagram and then write the equations with the forces and all of that. Okay, so let's do maybe even more questions. What I am trying to do is basically making you understand the concepts using very easy questions so that you never make a mistake. Okay, because next class I'll be doing friction. After that, problem solving, PYQs, NTA Abhyas, my questions. So that will be good level questions. So I want you to be prepared for that. So here comes another question, guys. So what is this? 3 blocks, one after the other. Let's start drawing the free body diagram. So let's show maybe M1 over here. Let's assume it is smooth for now. Okay, let's say this is M2 over here and maybe this is M3 over here. So M1, M2, M3. What are the different forces? Well, normal and weight kind of pretty much useless, not much of any use for finding anything. So I'm just going to ignore that, but I'm just showing it as arrow marks. This F is acting on M1. So I'm just going to show F over here. Okay. Tension 2 is between M2 and M1. So T2, if it pulls M2, it will also pull M1 behind. Correct? So be careful how the T2 is shown. On this block, it is this way. On this block, tension always pulls. So left side. Same way, T1 will pull M3 this way, but on M2, it will act this way. That's it. And last thing that you should remember is all of them will have same acceleration. Acceleration is the effect, never show it like a force. That's all. So now write the equations. Starting from M1, then M2, and then M3. Let's see, what are the equations? For M1, F is in the direction of A, so plus F. T2 is opposite, so minus T2 is mass into acceleration, M1 into A. That's for M1. For this guy, come on guys, think. T2 is in the direction, so plus T2. T1 is opposite, is mass into acceleration. For this guy, M3, what is it? Only one force, so T1 is equal to M3 into A. That's it, that's the equation, guys. That's all. Everyone with me? Okay. Now some of you will be wondering, sir, what if somebody takes the entire thing as a system? Is that allowed? Just say yes or no. Can I take M1 plus M2 plus M3 as a system? All the 3 things together as a system? Yes, definitely. If you take it as a system, now what happens is, it will then just become one single mass, M1 plus M2 plus M3, and there will be only one force, that is F. Yeah, there is normal and weight, I'm ignoring that. And together, all of them will accelerate with A. I'm like, sir, what about tension? What about tension now? Guys, you know what will happen to tension? Tension will be vanishing. You will be like, why? Because tension is now internal force. This tension will now become internal force. The moment it becomes internal, it is not acting on the system, it's within the system. Do not count it. That's it. Now the equations will be very simple. You will just say F is equal to M1 plus M2 plus M3, the whole mass, into A. That will immediately give the acceleration. Yes, Vidyasri, A will be F by M1 plus M2 plus M3. So this is how you can make equations, either taking system together or separate. Why I am doing it both ways? Because I want you to get into the habit of FBDs, writing equations, splitting forces and all of that. Moving to the next one. Block on an inclined plane. Most common situation. And many times people get confused which is cos, which is sine, whom to split, what to split, how exactly the angles are taken. Let's start with the simple one first. See guys, on this body, there will be obviously a normal force. This is a smooth surface, let's just assume it. And there will be weight acting on it. There will be weight acting on it this way. But I'm not so much bothered about mg because mg is at an angle with the normal. I think I'm going to split mg into 2 components. I feel I should do that. So there will be one component of mg which is going to act this way, and there is other component of weight which is going to act this way. I'm just splitting it into two components, okay? That's what I've done. And I know this entire thing is going to just accelerate downwards. It's just going to slide on this particular smooth surface. Now, I know you guys are wondering, sir, which component is this? Cos, sine, etc. There is a very simple trick to that. What is the simple trick? Understand. If you ever got confused into which angle is theta, which angle is not theta, the trick is this. Always draw 4 lines. What are you going to do, my students? 4 lines. How are those 4 lines? Horizontal, vertical. Okay? Horizontal, vertical. Then inclined, that is parallel to the incline, and perpendicular to the incline. This is perpendicular to the incline. Understood? How many parts did you get because of these 4 lines? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts you got? Everyone? Cool. Now, this is the parallel incline, parallel to the incline. This is the horizontal. Between these two, what is the angle? Between the parallel and the horizontal, what is the angle? Theta, right? So, between parallel and horizontal, over here, what will be the angle? It will be theta. This is clear? Everybody with me? If this is theta, na, then every alternate angle will be theta. Ignore this. Go to the next part. This is also theta. Ignore this part. This is also theta. Ignore this is also theta. That's it. So from this figure, which is theta now? From this figure, which is theta? Immediately you would have got it. This is theta. Everybody gets it? Because that's the angle between this line and this line. Vertical and perpendicular. That is theta. Cool. Simple, easy trick. Dividing it into 8 parts. That's the trick. So this is a trick, guys, for all of you. There is another trick. This is trick 1. There is another trick for you. Trick 2, which you can remember, which is cos, which is sine. So whenever you have a vector and you want to split it into 2 components, okay, if this is theta, the one which is closer, close, in Hindi it is called pass. Okay, tum mere paas aao, all right? So that's close. Pass, cos, resembles. So that is V cos. If you go away, you are committing a sin. This side is away from theta. You are committing a sin. So that is why this is V sine theta. Easy way to remember. Crazy, right? This is your trick number 2. Away, far away. You're going far away. You are committing a sin. You are coming closer. That's a good thing. That's cos, pass. Closer. Okay, that's all. So over here, which of the components is closer? This one. So that's why this is mg cos theta. This component is far, so it is mg sin theta. Understood? Clear? Very good. Now if you look in this direction, which is the perpendicular direction, I'm just going to write 2 equations, perpendicular and parallel. So if you look at the perpendicular direction, n minus your mg cos theta, that's not going to give you anything, that's 0. So n, normal force, is mg cos theta. In this direction, there is only one force, that's mg sin theta, is mass into acceleration. M and m gets cancelled, so acceleration will be g sin theta. That's how you get it. So it's not dependent on the mass just got cancelled. Clearo? Understood how these FBDs are drawn? So many tricks, so many concepts are involved. I've taught you everything. I'm teaching it to you as if you know hardly anything, guys. Very fundamental things I'm teaching you so that you slowly improve. You get the confidence. No matter where you are, how you are, you go from 0 to becoming a hero. That's my whole aim on coming onto this channel. Now this question, I'm going to give it to you as homework. I think you can solve it. Okay, this is your homework question. There is a block tied to a string. Few forces will be there, tension, weight, normal, something like that. You split it and tag me on Instagram. That's your homework. Cute videos around 2 hours. Alright. So you're going to tag me on Instagram. Done? Pakka? Show. Because you cannot post the answers. You will have to tag me on Instagram by clicking a photo of your solution, whatever you have done. That's your homework question. Another question. We'll see this. two strings connected to one string, suspending with a block being suspended from that one string. What are the free body diagram forces, and write the equations. Interesting, guys. Let's have a look again. So first of all, if you look at this block, there is going to be one tension over here, and there is going to be one weight below, and it is not accelerating. So therefore T up and weight below is going to balance. So tension will be weight, or tension will be just M into G. That's it. So this is one of the equations. Okay, fair enough. Next thing, look over here. There will be the same string, so same tension below, two new strings. So one tension here, let's say T2, another tension here, let's say I call it T1. T2, T1. Why? Theta, alpha. Angles are not same. It's not symmetric. If it was symmetric, T1, T2 will be equal. It's more, less, I don't know. What will you do next? I think you'll have to split, right? We'll have to split. Yes, Insta ID is the same thing, Captain_Shreyas Priya. Which one will you split? T1 or T2 or both? Obviously both of them. So let's try to split them. So one will be over here, the other will be over here. If this is theta, won't this be theta? Theta, theta, because two parallel lines. This line is cutting through it, so alternate angles. So closer will be cos, so T1 cos theta. Far away will be sine, so T1 sine theta. Perfecto, amazingo. Let's see what's next. T2 will be split into two components. One here, one here. Obviously, if this is alpha, this is also alpha. Because again, two parallel lines, this line is cutting through, both are alternate angles. The closer component is cos. So this is T2 cos alpha. What is this? Sine. So this is T1 sine alpha. Everybody with me? Once this is done, all the forces are shown. Write the equations in y and in x. Observe carefully. In x direction, for this joint, for this small joint, what are the forces? What are the forces? Come on, my dear students. Think about it. In x direction, T2 cos and T1 cos are cancelling each other. So can I not say T2 cos theta minus T1 cos theta is giving nothing, or T2 cos theta therefore is equal to, this is T2 cos alpha, it should be, my bad, it should have been alpha, minus T1 cos theta is 0. So T2 cos alpha will be T1 cos theta. That's it. Perfect. Next, in the y direction, what will you say, guys? This force and this force together cancels this T force. So T1 sine theta plus I should have put T2 over here, my bad. This is T2 sine alpha will be equal to T1 sine theta and T2 sine alpha, both are upwards. This will cancel T, or if you don't like this, no problem, just put a minus sign and then say is equal to 0. Therefore, T1 sine theta plus T2 sine alpha will be T, and this T is nothing but mg. That's all. This is another equation. Very nice. So this is how you make equations. This is how you draw free body diagrams. Are you getting little bit more confidence? Are you confident after attending this particular part of the lecture, guys? Everybody, can we move ahead to the next part? Ready? With full josh? I hope you have not dried up. I hope you have not given up. I hope you're not sleepy. I hope you are still fully energetic to go to the next part. Okay? Because I'm going to take in that effort. We'll go to pulley problems, constraint problems, multiple pulleys, and then we will end the class with pseudo force. That's the last part of today's lecture. Okay, so let's start with pulley problems. And this is the most common pulley problem. I'll be giving you other pulley problems in the final problem solving class. Here I'm just going to teach you certain techniques which you should know. Whenever you get pulley problems, generally the masses will accelerate or maybe at rest. So in this kind of situation, which is also called as the 8-wood machine, the most common situation. One block goes up, the lighter one, the heavier one goes down. Let's say the heavier one goes down with some acceleration a, the lighter one goes up with the same magnitude a. Why? Because it's the same string. If this goes down, this has to go up by the same amount. What does a pulley do? You might have seen pulleys. Pulleys look something like this. Pulleys look something like this. Pulleys basically help in changing the direction of the tension. The moment you have a pulley, it changes the direction of the force. The one which was going up will come down. The one which was going right will go left. Something like that. So it changes the direction of the force. That's what it does. And it also, when you have multiple pulleys, you will see you need less effort to pull or push things. Like in a well, yes, when you are to draw water, the water has to be drawn up, but you are applying the force like this. So yes, that's a good example. Now, the other forces acting on these blocks are, one is tension. If this is the same string going till here, shouldn't the tension also be the same? Same TT, same string, just the direction has been changed like that. That's all. There is one more force over here, which is M1G, and one more force over here, M2G. So let's see if you guys can think about this. If I ask you what are the equations for A and B, write it down in the chat box, guys. What are the equations? Very good, Vidyashri, already writing it. For A, what will the equations be? Think about it. Think carefully and put it up, guys, in the chat box for A and for B. For A, yep, A is going up. So whatever is up is positive. So T will be positive. M1G is down. So minus M1G is equal to M1 into A. Correct. And for B, guys, B is going down, right? Acceleration is down. So anything down will be positive. So plus M2G minus T is equal to M2A. Two equations, two unknowns, T and T. Solving them together, the answer that you get, I'm not solving it over here for you, just remember this final result. Bigger mass minus smaller mass, the whole thing into acceleration due to gravity upon the total mass. That's the final answer that you get after solving this. Also, the value of tension that you get, you should remember this, 2m1 m2 upon m1 plus m2, the whole thing into g. If you remember this, many times you don't have to write all these unnecessary steps. Directly you can find the answer. So try to remember this formula. Is that okay, everyone? All right, great, very good, Vidyashri, very good, Dharni, very nice. Some of you remember, Dharni, I think you missed a G over there. Yeah, everything else is fine. Very good. Keep this up. Now, this question, you're going to solve it at home. Hint, tension, same string, tension. Weight, normal. Weight, normal not needed because I'm only considering vertical motion. This goes here, this goes down. Complete the FBD and solve this as homework. You're going to tag me. Where are you going to tag me the homework? As story or maybe as a post, whatever, at captain_Shreyas. At captain_Shreyas. That's my Instagram handle. So that's where you're going to tag me, guys. Everybody fine? So this is your second homework problem for today. Everybody will be able to do it. I'm very good, Danish. Thank you so much, bacha. Don't spam. Same formula, even if this is bigger, this is smaller. Just that the signs will change, or you can bring this guy here and that guy there. So if the other one is heavier and the other one is lighter, then just flip the sides. M1 will come here, M2 will go there. Okay, that's all. Great. Now comes the concept of multiple pulleys. You might have seen this. Cranes, elevators, multiple pulleys. There are systems where you might have to move something by some amount, the other thing will move more. Something you will pull by small force, the other thing will apply more force. So multiple pulleys are generally used to change the magnitude of the forces and to change the motion of the objects by different amounts. Like in cranes or in elevators or complex machineries where it has multiple pulleys and belts over it. Spam is writing the same thing again and again. Danish, whatever you are doing. Okay, please don't spam. Will you send this session PDF in Telegram? Definitely, Vijay. Have I ever done that? I will teach and I will not send the PDF. There is no use if I do either of, only do one of them, right? And I don't do the other one. So both the things are important, lectures and PDF. Now look over here. Okay, it might be little difficult initially, but you will get the hang of it. And I'm going to teach you a brilliant trick. So whenever you see multiple pulley problems, if you get scared, after this lecture, you will not be scared. Okay, and if you are not scared, after that trick, please put up a fire in the chat box, fire emoji in the chat box. If you do not get scared after I teach you that trick. I know right now you might be a little bit skeptical about solving the problem. Don't worry, we'll see. This block can move left or right, connected by a string, passes over a pulley, passes over another pulley, goes up and tied at the top. Another mass hanging from below. What happens when you leave it? This mass has its own weight. So this weight will pull it down. As it goes down, this pulley also goes down. So let's try to draw it in the new situation. So this pulley has gone down over here. Like you can see, the center of the pulley also has gone down. This triangle will also go down. This mass will also go down. Now if this mass has gone down by small amount of x, don't you see this point which was in contact with the rope is now come down here. So I feel that there is some amount of string which is needed here. Do you see that? And this point which was in contact with this string, tangent, that point has come down over here. So I need a certain amount of string here and here. If I go down by x, center comes down by x, those 2 points are also x and x. I need the string. If I need the string, where will it come from? Has to come from somewhere. Will this guy give? Like, no, sorry boss, I have been tied. I can't give you string. Okay, can you give me the string? This guy is like, okay, I can move. I can give you the string. How much do you need? I need 2x. Okay, if you need 2x, I need to move 2x. So this guy will be like, okay, fine, I will move over here by 2x. It's basically supply and demand. This is nothing but your supply. This is nothing but your demand. This is trick number 1, visualization. But often people make silly mistakes in visualization. And often it becomes little bit difficult. But I will give you an easy trick just like I promised you. What is that easy trick? Observe. Observe. This was one method or one trick, supply and demand. The other trick, observe carefully. So what was this? This was M1, right? Okay, great. This is like this. This is another pulley attached over here. This is like this. Okay, this is your M2 mass. The second trick needs another piece of knowledge, and that other piece of knowledge is whenever you have a pulley and there are 2 strings coming out from here and 1 string coming out from the center, the logic goes like this. If this part has tension T, because this is the same string connected, obviously this tension will also be T only. Look at this. If this part has tension T, this is the same string wrapped over the pulley, so this will be also T only, right? Correct? Now just think. This part has new string, so new tension. How much will this tension be? Put it up in the chat box. How much will this tension be? Just put it up in the chat box. Hello Mahadevi DH. Come on guys. T and T is a massless, light pulley, no mass. So forces should just cancel out each other. Exactly, Madhumita, Roshni, Vidya, Anish. Can this part be clubbed with elasticity? Definitely. Obviously 2T. T, 2T. Balance. So this is just balancing. Very good. If you know this concept, you will understand the trick. Observe. I hope you can see there is 1 string over here. There is 1 complete string over here. So in this particular string, there is this tension, there is this tension, there is this tension, there is this tension, there is this tension. So there is T, 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 T over here. This is how the tension flows throughout. There is only one string over here. There is one hanging string, this part. I feel this part, T and T, just like T and T together will make it 2T. This will be 2T, right? Great. Now this is the logic that you have to use. Observe carefully. Write M1 and write M2. M1, M2. What is the tension force on M1? What is the tension pulling force on M1? It is T. What is the tension force on M2? On M2, this is the tension force. It is 2T. Correct? It is 2T. Guess what? The accelerations and velocities and displacements will be exactly inverse. So if this is 1T, this is 2T, this will be 2A and this will be 1A. If this is 2V, this will be 1V. If this is 2X, this will be X. As simple as that. Isn't it easy formula, guys? Inversely related to each other. That's all. So all I'm going to say is M1 is going to accelerate twice and M2 is going to accelerate once. You can see it's exactly the same thing. This is X, this is 2X. This is A, this is 2A. This is X, this is 2X. This is V, this is 2V. That's it. Loved the trick? Put up a fire emoji and smash the like button and also hit the subscribe button right away now. Isn't it amazing and fabulous? We are going to do 1 or 2 more problems so that you get a hang of this trick. Okay? Don't worry. Cool? So let's apply this trick to another problem, guys. Let's apply this trick to another problem. Observe now carefully. I think you can find one string somewhere. I think this is tension, this is tension, this is tension. Same string going like this. Tension, tension, tension. T, T, T. This part has how much? 2T. Okay? I hope you can see that. So let's start writing for M1 and M2. On M1, the pulling force by tension is 2T. On M2, the pulling force of tension is just T. So it's always inverse. Correct? So I'm just going to say this will be A and this will be 2A. That's it. Done. So M1 will have acceleration of A and M2 will have an acceleration of 2A. How many seconds? Barely 10-15 seconds. Barely 10-15 seconds. Okay? Yes, Vidya, I'll be coming to spring and wedge related questions in a separate part. Don't worry, in problem solving sessions. Usually spring questions are coupled with, weighing machines or spring balances, or generally with SHM. I have not seen complex questions. I'm not talking about AIMS, I'm talking about NEET. I've not seen complex questions of Newton's laws of motion where they combine a spring with tension, multiple angles, 2 angles, or at an angle, and then acting. No, you will not see those things. It will happen maybe in mains, that too the mains difficult part, or in advanced or KVPY. KVPY is cancelled exam. Advanced, there is a separate channel for that, JEE advanced JEE channel basically. That's where I'll teach. But for NEET perspective, don't solve very complex questions. It will not come. You'll just spoil your head and you'll be like, oh my god, I don't know anything. So don't do that. One more question. Let's see how many of you can do this. Come on, guys. Okay. Again, start looking at the FBD. Start seeing how many strings are there, how many tensions are there, and all of that. I can see this string going like this. Okay. So T, 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 T. Oh, the string in between. I'm just going to call it 2T. Okay, I think most of it is done now. So M1, M2. M1 has T, M2 has 2T, inversely related. So this is 2A and this is A. Done. So M1 is 2A, M1 is 2A, and M2 is A. So that's about it. So simple, guys. This is crazy. Yeah, we'll do it in the form of equations as well. Vidya, you can do it, but that is generally more complicated. I don't feel that you should waste so much time solving it by a proper method, because in NEET you don't get complex questions like, I know some of you might have seen these kind of questions, or you will see somewhere there is one block here, there is one pulley here, then it goes like this, it goes like this, it goes like this, and there is one block here, and then there is a block here, and then it goes like this, and then there is pulley over here, or something like that. You'll be like, sir, such a difficult question, sir. These kind of things don't come, they don't even come in JEE, forget NEET. In JEE only they don't come. Some people just waste time. It doesn't come. Okay? So don't waste. Do what is required. See, what is the biggest problem in preparation? One thing is examination, other thing is preparation. If you are running for a marathon, prepare for a marathon. If you are running for a sprint, prepare for a sprint. If you are saying, sir, I have to run this running race, and then you ride a cycle, or you take a bike and then go on that track. What is it? You are making it too easy. You are not practicing. Or if it's a bike race and you are like, no sir, I'm going to make my preparation very hard and I'm going to run on that Formula 1 track. I'm going to run on that Formula 1 track. Sir, I'm preparing very hard, sir. I'm training myself very hard, sir. See this. I'm running so much. I will race against the Formula car. What? Really? What is the use? Preparing hard. You are preparing for Formula 1 race, or you are preparing for the bike race, and you are running on the track? No use. Makes sense, right? Got it? Got the point? Okay, let's talk about frame of reference. Frame of reference. Yes, this is for NEET channel. Yes, Vidya series, exclusive NEET channel. And guys, I don't know, you should feel proud staying on this channel, attending these classes. This is the only and the first NEET English channel. We were the ones starting the English JEE channel. I was there on the JEE English channel. There were other channels before. I won't take names, but there were. And we have been consistent. It's almost going to be now 3 years this year. And we have been consistent over there. We have proved our worth. So many students got into JEE, not just mains, but also advanced, went into IITs because of that YouTube channel. We are here. I am here now so that you can get into AIMS, you can get into AFMC, you can get into any college, because I am here now. And you know I don't leave anywhere, right? I am here only for you guys. So make sure you make the best use of it, guys. You guys are extremely, incredibly lucky to have an English NEET channel for all of you. Luxury Hitler, why is tension inversely proportional to acceleration? There is a big theory for that. Basically, the net work done by tension is zero because the string is inextensible. So if you apply work kinetic energy theorem, you see that total work is zero. So tension into x, the summation is zero. So that's why it comes out inversely proportional. Okay, so that logic is there, but don't worry about it. Now, frame of reference just means perspective or point of view. Example, maybe there is a bus or a car, or maybe there is an aeroplane, okay, or maybe there is just a lift, which is going up or down. Imagine a person in each case, a person sitting inside, or the person standing on the plane. This is imaginary person, like you have imaginary numbers in maths. This is imaginary person. He may not be real, he's just hypothetical. You can talk to him, you can make him do anything, he will dance also for you. This is your observer. Who is he? Observer. That observer will have y-axis, x-axis, z-axis, etc. Y-axis, x-axis. That is called as the frame of reference. What is it called? Frame of reference. Perspective. What he sees. He sees doing this. Like for example, if you are going in a bus, your friend is sitting beside you. For you guys, the person sitting beside you is at rest, right? For you guys, the person sitting beside you, your friend, is at rest. Or for a person standing outside, he is moving. So perspective changed. Frame of reference changed. So motion is relative. So that is the importance of frame of reference. Should I take notes for frame of reference? I think you should, Anish. Although it is a concept, but you will be applying it. So I feel you should keep it as notes, just as a short note. Cute videos, I will do all the major chapters. I'm not sure if I will be able to complete all the chapters. At least the high weightage and medium weightage chapters I'll be doing it, bacha. Okay, don't worry about it. All the medium weightage, and mainly I'll be doing full syllabus mock test and everything. So I'll make sure that you will get 150 plus. That is one thing I can make sure. Okay, 150 plus, whatever chapters you need, I will be doing it. Session up to what time? Up to, oh my god, 10 more minutes, right? Hardly 10-15 more minutes. Now, there are two kinds of frames. Two kinds of frames. One, inertial. Second, non-inertial. One, inertial. Second, non-inertial. Inertial means, remember, inertia is the state of rest or motion. Non-inertial means not in the state of motion or rest. Exactly what it is. Imagine some observer sitting on something moving with a constant speed. Inertial. Imagine an observer sitting on something which is at rest. Inertial. Imagine an observer sitting on something which is going like this. Which is going like this. That is non-inertial. Changing velocity, accelerating. Imagine an observer sitting on a body which is slowly increasing the speed. Accelerated frame, non-inertial. Imagine somebody sitting in a bus or a car or a truck or an observer who is decreasing the speed, brakes. Non-inertial. So non-inertial means acceleration, inertial means constant velocity or at rest. Is that clear? So guys, you only think and tell me, if you are sitting in a train which is going from one station to another station, will it be inertial or non-inertial, or it depends on what it is doing? Yes, ground frame is inertial, correcto. Ground, earth is not accelerating, zoom karke. Is earth flying or zoop karke? No, right? It might be accelerating little bit, but you ignore that. So most of the time a train moving will be inertial unless it's just starting from the station when it is accelerating, or when it is stopping down, then it again becomes non-inertial. So a train will be non-inertial while acceleration, while going with constant speed, inertial, while slowing down, again non-inertial. Very good. So it depends. It depends what is the train doing. I hope this is clear. Now what is the need of dividing it into two parts? The need is like this. In inertial frames of reference, Newton's laws of motion are basically valid. Verified account. Laws of motion are valid. But the moment you go to non-inertial frame of reference, the Newton's laws of motion are invalid. Now this is a big trouble, because how are you going to solve problems where you are sitting inside a bus or a car or a train or a plane or a lift which is accelerating? You cannot apply Newton's laws of motion. That creates the trouble. So that's going to bring us to the next concept. Observe now. Imagine this is an observer. What kind of observer? Non-inertial observer. Let's say this frame itself accelerates with A. This is the frame's acceleration. Maybe the plane, the lift, the train, bus, car, whatever. It's accelerating with A. That guy happens to see some body of certain mass, and maybe there are multiple forces acting on it. Maybe F1, F2, F3, F4, etc. So if he applies net force is equal to mass, maybe because of that it has some acceleration, mass into acceleration, he will see that this equation will not be true. Reason being, it's a non-inertial frame. Newton's laws are not valid. Newton's laws is not valid. Then he'll be like, oh my god, what do I do? Nothing, just do a small modification. What is that small modification? Just write net force plus a pseudo force plus fake force, not a real one, only on paper, only over here, it is not actually there, is equal to mass into acceleration. Suddenly the Newton's laws of motion become valid. Otherwise it will not be valid. This is a fake force. It's not a real force. It's only on paper, just for adjustment, like settlement. That's all. You will be like, sir, where do I show this force? Simple. this force is going to act on that mass, but always opposite to this guy's acceleration. Where is this guy accelerating the observer? That way. So the pseudo force will be exactly opposite, this way, and the magnitude of that pseudo force will be mass of that guy into acceleration of the frame. That is what the value of the pseudo force is. Don't put minus Fp. That direction has been already taken care of. This is all a vector equation. Think of it like this. This is a vector equation, bacha. Already the sign is inside of it. Fp will be something which is already taken into account the direction. So don't put minus sign. Yeah, speed of light is independent of any frame. Light is very cool, very true. Fake things make things complicated, or I would say luxury Hitler, fake things solve our problems. So maybe it is cool. Okay, so is this clear? This is the most important theory pointer of pseudo force. I've also put up the definition formally. Pseudo force is also a fictitious character. You might have heard in stories or movies. It's a fictional character. It's not real. Harry Potter, he's not real, right? Correct, right? Iron Man, he's not real. Batman is not real. Unless you are wearing a cape and just flying and jumping out of the buildings. Or inertial force is the force which is described using non-inertial frames. It is just to satisfy Newton's laws of motion. Now, Pranav, where do you have exams in 10 days? There is a lot of time, bacha. NEET is in May. Chill Madi. Now, imagine you are driving in a car or you are in a bike. You are sitting behind somebody. Just imagine. Zoom! You accelerate like this. What will happen? What will happen? You will fall back, right? Oops, like this you will fall. Hai na? So when you accelerate, acceleration is that like that, you are a non-inertial frame. Acceleration is that way. Oh, non-inertial frame, pseudo force. Where will pseudo force act? Backwards. That's it. That's how easy it is to remember pseudo force. Pseudo force will act backwards. That's why you feel that push back like this, you go behind. But when you brake, your deceleration, there is acceleration behind. Pseudo force will be ahead. So when you brake, you go like this, you fall, because pseudo force will push you forward. Correct? Very nice. All right. So maybe we can do some questions on this. Everybody with me? For school exams and mock test. Pranav, don't prepare for local exams. Don't prepare for the small exam. Prepare for the main exam. You are not preparing for mock test. You are preparing for NEET. If something is not done, leave it. If school test is not done, if you just study it for the sake of it, gone. There's no use, na? Newton's laws is local law. Local law means you can say it is only valid in certain situations, not a universal law. Yeah, you cannot say that it is valid in all the times. So that's why you use pseudo force. Why pseudo force is opposite in direction? That is just to make the things valid. It's just by observation, luxury Hitler. Okay, there are derivations for that, but that's why I give you the example. When you accelerate, what happens? Zoom karke, you feel a force behind. So that is the pseudo force. So wherever you accelerate, you feel. Because of inertia, you are pulled back. You try to stay. That's why pseudo force acts behind. Is that okay? I'm so glad, Pranav. Okay, so let's try to solve this question. Look at this question. What is it? Magnitude of the pseudo force by the driver of the racing car. Okay, so this is the racing car maybe. Okay, I'm just showing some random thing, guys. This is the driver. This car is accelerating that way. So obviously this guy is going to experience a pseudo force this way. This is going to experience a pseudo force this way. This is the car's acceleration. Can I find the acceleration? I think so. It is final minus initial velocity by time. Equation of kinematics. Final is 60. Initial is 0. Time is 8. So it's 60 by 8 meters per second square. What about pseudo force? Pseudo force, guys. Come on, guys. What about pseudo force? Pseudo force is magnitude wise mass into acceleration. What is the mass? What is the mass? Where is it? 80 kilos. So 80 into acceleration is 60 by 8. 60 by 8. So that's going to be 10 into 60, which is going to make it 600 Newton. Where is that option? Very nice. Option D. Some of you got it. Excellent, guys. Very good, very good, very good. One last question coming up on your screen. And remember, you have to always tag me on the homework question. My Instagram handle is captain_Shreyas. Go ahead and tag me in the 2 homework questions which I have given, because those are diagram based questions. Person standing on elevator, which situation pseudo force is acting upwards? This is the elevator, this is the person, okay? In which situation do you think the pseudo force on the person will act upwards? Come on, my dear students. Pseudo force has to act upwards. That only means one thing, the lift has to accelerate. Lift acceleration has to be downwards. The pseudo force always acts opposite to the acceleration. Correct. Excellente. That's the correct answer. Option B. Perfect. Make sure you join the Telegram channel. The link is there in the description box. That's where you're going to get the entire session PDF. And obviously all the important updates, whatever lectures are going to come up, are going to be put up on the Telegram channel. And if you want more additional resources like lectures, you want assignments, you want PDFs, you want test series, you want rank prediction, you want doubt solving, you want personal teacher, or you want even live classes, you want discussion of PYQs, everything at one place in a very systematic manner, and you're not very really happy about the coaching that you're doing, go ahead with the Crash or Crash Plus. Crash obviously has all the things whatever you require, but if you need additional things like personal teacher, live discussions and other things, go with the Crash Plus at very good prices for all of you, even with EMI options available. So that was this session tonight. Tomorrow at around 7 or 7:30 I'll be taking the remaining part of transistors. That's your 12th standard topic of semiconductors. And day after tomorrow at again 9 o'clock we'll be doing friction. And then after that day we are going to do problem solving, NTA Abhyas PYQs together of Newton's laws, laws of motion, pulleys problems, pseudo force, friction, everything together in that amazing problem solving session. So that's the schedule for this week. Make sure you stay tuned, and if you have missed any classes, watch it. Stay subscribed so that you do not miss. Join the Telegram channel, again you will not miss. And come on guys, show your love. Thank you so much, Anish. Bye bye. Have a great night. Luxury, Hitler, Anish, Roshni, Tarika, Niranjan. Bye bye Vidyashri. Bye bye Madhumita. Bye bye Deva. Bye bye Senthil. Bye bye Sudarshan, Niranjan, Navya, Sampath, GV. Thank you so much. Have a great time. Bye bye Mitra. Bye bye everyone. Take care, stay healthy, stay safe, and keep working hard. This was Captain Shreyas, and I'm signing off. Hasta la vista.